Finding concentration from redox titration requires writing the proper ionic equation for the redox reaction. This is a past paper question from AQA A Level Chemistry that involves a redox reaction between hydrogen peroxide and potassium manganate 7. The first part of the question asks you to give the ionic equation for the reaction between potassium manganate and acidified hydrogen peroxide. They already gave you the half equation for the oxidation of hydrogen peroxide here, and you need to write the full equation. So you need first to write the half equation for the reduction of the manganate. So the manganate MnO4 minus, this is the manganate 7, that will give you the N2 plus, and then you need to balance this one first with the oxygen by adding 4 water molecules on the right hand side, and then you balance the hydrogen by adding 8 hydrogen plus, and then the number of electrons on the left hand side. In total there is 7 plus, and on the right hand side there are 2 plus, so remaining 5 electrons. Now you need to combine these two half equations together, but bear in mind that you need to have the same number of electrons on both sides. So to do so, there are 2 electrons on the oxidation half equation and 5 electrons on the reduction half equation. So you need to multiply the oxidation times 5 to make it 10 electrons, and the reduction times 2 to make it 10 electrons. So you end up with 5 hydrogen peroxides that will give you 5 oxygen plus 10 hydrogen and 10 electrons. And for the other equation, then you have 2 manganate plus 16 hydrogens plus the 10 electrons that will give you 2 Mn2 plus and also the 8 water. Then combining these two together, the final ionic equation will be 2 manganate plus 5 hydrogen peroxide plus 6 hydrogen plus, that will give you 5 oxygen plus 2 Mn2 plus 8 water. So this is the ionic equation. Now to find the concentration from the titration, we need to know that the ratio for the moles of hydrogen peroxide to manganate is 2 to 5. So now the first part of the question, we need to find because they titrated hydrogen peroxide with the manganate. So we need to find the number of moles of the manganate first, and then the number of moles of the hydrogen peroxide will equal 5 over 2 the number of moles of manganate. So the number of moles of the manganate will equal the concentration times the volume in decimeter cube. So the concentration here provided to us is 0.02 mole per decimeter cube times the constant in the volume in decimeter cube. The volume here is 35.85 centimeter cube. That's the volume of the manganate. So this is 0.03585 decimeter cube, and the number of moles is 7.17 times 10 to the minus 4 moles. And then the number of moles of hydrogen peroxide then will equal that value times 5 over 2, because the ratio is 5 to 2. So it's 7.17 times 10 to the minus 4 times 5 over 2, and that will give you the number of moles of the hydrogen peroxide, which is 1.793 times 10 to the minus 3 moles. Now they use 25 centimeter cubed of a diluted hair bleach solution, or the original solution contained 5% of hydrogen peroxide. They want you to find the concentration of the original hydrogen peroxide. So let's first find the concentration in the diluted solution. So concentration in of hydrogen peroxide in the diluted solution, which is the 25 centimeter cube, will equal the moles over the volume in decimeter cubed. So this is 1.793 times 10 to the minus 3, and this is divided by the volume in decimeter cube, which is 0.025 a decimeter cube. The concentration now is 0.0717 mole per decimeter cube. So now we need to find the concentration of the hydrogen peroxide in the original solution. So this 25 centimeter cube is actually had 5% of hydrogen peroxide. So we need to find the concentration of the original hydrogen peroxide. If it's 5%, then that means that will be the concentration of the diluted solution times the dilution factor, or which is 20, or it's 100 over the 5, and that will give us 1.43 mole per decimeter cube. So this is the concentration of the hydrogen peroxide, the original solution.